Welcome back. Today, we're diving into a seriously clever design pattern that's all about doing more with less. It's called the Flyweight Pattern. And trust me, it's an amazing trick for making your applications way more efficient by fitting a ton of objects into memory. But to really get what this is all about, let's start with a puzzle. You ever wonder why a really intense video game might run like a dream on a high-end PC, but then completely crash and burn on your friend's computer that's just a little bit older? Well, the answer to that question reveals a really common and very costly programming problem. Okay, let's get right into the story. Picture a game developer, and they're building this awesome new action game. Their vision, an incredibly realistic particle system. I mean, they wanted the screen to be just absolutely filled with chaos. We're talking thousands of bullets, missiles, little bits of shrapnel flying everywhere. And to make this happen, each and every one of those tiny particles was its very own object, carrying all the data it needed to exist in the game. Now, this is where things get really interesting. See, each of these particle objects had its own unique data, right? Like its specific coordinates and its speed. But it also stored its color and its sprite, the actual graphic. So for every single bullet, the game was storing the exact same heavy sprite data thousands and thousands of times over. And that, right there, is our culprit. This massive, massive duplication of data was just eating up RAM like crazy. Sure, on a powerful machine with tons of memory, maybe it's fine. But on a computer with less RAM, the game would just run out of road, run out of resources, and crash. The developer had a huge problem on their hands. So the solution here isn't just about throwing more memory at the problem. Nope, it's about thinking about an object's data in a totally different way. And this is the absolute core idea of the flyweight pattern. You split an object's state into two different kinds. First up, we have what's called the intrinsic state. This is the part of the object that's shared, it's constant, it doesn't change. The best analogy is a library book. Think about its title, its author, its ISBN number. No matter who checks that book out or when, those core details are always the same. This is the heavy, reusable chunk of data. And then on the flip side, we have the extrinsic state. This is the stuff that's totally dependent on the context, it's unique, and it changes all the time. For that same library book, the extrinsic state would be who the borrower is and what the due date is. This information is lightweight and it's specific to each individual situation. And here's where all just clicks into place. The book's core identity, that intrinsic stuff, is shared across every copy. But the details of each loan, the extrinsic stuff, are totally unique. The flyweight pattern does exactly this. It separates that heavy, shareable data from the lightweight, context-specific stuff. So, it's a powerful idea, right? Create just one shared object for the bullet's sprite and color. But that leads to a really important question. How do you manage and hand out these shared objects without making a mess? Well, that's where the Flyweight Factory comes in. Think of the Flyweight Factory as a gatekeeper, or maybe a super efficient librarian for our objects. When the game needs a bullet, it doesn't just create a new one. It asks the factory. The factory first checks its pool and says, hey, do I already have a bullet object created? If the answer is yes, it just returns that existing one. If not, it creates a new one, stores it in the pool for the next time, and then returns it. This system guarantees we only ever have one single instance of that heavy intrinsic data. Now, using this pattern has a massive impact on efficiency. It totally solves our developers' memory problem. But, like any powerful tool, it's not a free lunch. It comes with some costs. Let's take a look at the final verdict here. I mean, just look at this. The visual tells the whole story. The difference is night and day. We went from storing thousands of these huge, heavy objects to just a handful of shared flyweight objects. The memory savings are just dramatic. So this is the crucial point. It's all about this trade-off. The pros are huge, right? We save tons of RAM and performance gets better. But the cons are very real. Separating the state like this makes the code more complex. A new developer joining the team might look at it and get pretty confused at first. You're essentially trading simplicity for a big gain in efficiency. So, given that trade-off, this pattern is definitely not a one-size-fits-all solution. It's a specialized tool, and it's really only effective under a very specific set of circumstances. So, how do you know when it's the right tool for the job? You should start thinking about the flyweight pattern when your app is creating a massive number of very similar objects, and you can see that it's causing a serious memory bottleneck. The absolute key here is that a big chunk of each object's state has to be identical and shareable. If every object is totally unique, this pattern isn't going to help you at all. And that brings us to our final thought for today. The flyweight pattern is an incredibly powerful optimization tool, but it forces us, as developers, to ask a really critical question. Where do you draw the line? At what point does the search for performance create a system that's just too complex to maintain in the long run? It's a balance every single one of us has to find. Something to think about.